So a sample of hydrogen gas at 735 torr is found to have a volume of 215 milliliters. If the gas is allowed to expand to 285 milliliters without a change in temperature, what is the pressure of the gas? So what you want to do is you want to figure out first what are our original, so what's our original pressure, our original volume, and then we want to find what our final pressure is and our final volume. And let's see what we know about these things. So do we know the pressure to start with? A sample hydrogen gas at 735 torr. So we know the original pressure, 735 torr. Okay. Do we know the original volume? Yes, 215 milliliters. So we take 215 milliliters. Okay. Do we know the pressure afterwards? If the gas is allowed to expand to 285 without a change in temperature, what is the pressure? No, we don't. That's going to be what we're looking for. Do we know the final volume of the gas? Yes, it's expanding to 285 milliliters. So we'll set up our equation here. Our Boyle's law says P1 V1 equals P2 V2. And so our original pressure here is 735. Yeah, that's not what I wanted. Get rid of that. So 735 torr times V1, which is 215 milliliters, equals P2, which we don't know, times the V2, the volume, 285 milliliters. Okay? And so if you get out your calculator here, that we'll work on, say, the left side here. And so doing that, we get 735 times 215. And when I do that, I get 158,025. No rounding yet because we haven't gotten to the answer yet, is equal to 285 times P2. Divide both sides by 285. And when you do that, we get a total of 554.47. Significant figure-wise, we have 3 significant figures here, 3 here, 3 here. And so as a result, our final answer will have 3. And so our answer here would be 554. What unit do we want to use? Well, the unit of pressure that we have here is going to be the same as the unit of pressure we had before. And so since we don't know this one right here, then we have to look over here. So the pressure we had over here was in torr. That means that our answer is going to be in torr. Notice also we made sure we had the same unit of volume on both sides, milliliters on both sides there. And so our final answer for the pressure is 554 torr. Now let's see if this makes sense. We started off with a pressure of 735 and a volume of 215, is that the gas expanded to 285. And so if the volume expands, then we would expect that there's a less dense gas, there are going to be fewer impacts on the surface, and so the pressure would be lower. And so we went from 735 down to 554, so sure enough, the pressure got lower just as we expected. So this is how you'd go about using Boyle's law. So the balloon with a volume of 2.2 liters at 20 degrees C is heated to 90 degrees C. What's the new volume of the balloon? And so to do this, we know that we have the original volume. V1 is 2.2 liters. The original temperature, T1, is 20 degrees C. The final volume, V2, we do not know. That's a question mark. The final temperature, T2, is 90 degrees C. Okay, so we're going to set up Charles's law. And so V1 over T1 equals V2 over T2, like that. And so doing this here, V1 is 2.2 liters over the temperature. Temperature T1 is 20 degrees C. We can't use 20 degrees C. We're going to have to instead replace that with that in Kelvin. And so Kelvin would be 20 plus 273.15, so we get 293.15 Kelvin. So that's what we have to use here, 293.15 Kelvin. Okay? And so continuing with this is that this is going to equal to V2, which we don't know, over T2. T2 is 90 degrees C. Can't use that there. And so we're going to have to convert 90 degrees Celsius into Kelvin. And so 273.15 plus 90 equals 363.15. I'm doing my math right. Kelvin. So we put in 363.15 Kelvin is what we get for this. And so now we're going to go ahead, set up and solve this. And so solve for V2. And so we say 2.2 times 363.15 divided by 293.15. And so I get 2.72 for V2. Significant figures, looking at what we've got here, we have 2 here. Since this goes to degrees, that's 2. This goes to degrees, that's 2. So our answer should have 2. So our final answer for V2 is going to be 2.7. Units are going to be the same as what we had over here. And so in this case, that's going to be liters. So 2.7 liters is our final answer. And so that we went from 2.2 liters to 2.7 liters by heating it up. So a tire is filled to 33 psi, pounds per square inch, when the temperature is 0 degrees C. If the temperature rises to 30 degrees C, what is the pressure in the tire? So let's set this up, is that we have P1, the original pressure. In this case, is 33 pounds per square inch, 33 psi. Not a normal pressure unit, but we said it's acceptable to use any pressure unit as long as it's the same before and after. So we should be good here. The original temperature is 0 degrees C. Okay, so we got that. The final pressure, P2, we don't know what that final pressure is. The final temperature, T2, in this case is going to be 30 degrees C. So let's set up Gay-Lussac's law. So P1 over T1 equals P2 over T2, like that. And so the original pressure in this case is 33 psi over the original temperature, but the original temperature is in Celsius, so once again we can't use that. We'll have to convert. So we add 273.15 to 0, get 273.15 Kelvin. And then once we've got that, is that we set up the rest of the equation, equals P2, we do not know what that is, over T2. T2 is 30 degrees Celsius, but 30 degrees Celsius is not in Kelvin, so we have to add 273.15, and we get 303.15 Kelvin. So P2 is 303.15 Kelvin. And now it's just a matter of putting it into the calculator and solving. And so we take 33 divided by 273.15, and then we take that and multiply it by 303.15 to solve for P2. And so when you do that, is you end up with a P2 of 36.624. Significant figure-wise, we have 2 significant figures here. This guy looks like 1, but since that's sort of exact, it's exactly 0 C's here. When we converted this over, it became 273.15, which we're not going to affect. It'll basically be, okay, since we added these two, we said in order to find the 273.15, we had to add 0 to that. 0 has 1 significant figure to it in this case. We added 273.15 means it's going to be rounded to the ones place here. And so that means we'll have 3 significant figures from this temperature. Same thing from this temperature right here. Since 30 would be rounded to the ones place, this will be 3 significant figures. And so our answer will have 2 for our final one. Remember your addition significant figure rules. We don't use those very often. But so if you do that, you end up with 37. And so our final answer here is 37. The unit is PSI because the original unit was PSI. We can use any unit of pressure we want to as long as it's the same on both cases here. And so going from 0 degrees C, it's about 32 degrees Fahrenheit, to 30 degrees C, which is up a pretty high temperature. That's like hot summer temperature right there. It would go from 33 psi to 37 psi just by increasing the temperature. And that goes over your basic gas laws. And next time we will look a little bit at what happens when we have not just pressure and temperature changing, but we have all 3 changing all at the same time.